Law, first gas law we're going to deal with is the law of partial pressures. So it's actually pretty simple to deal with this, but there are a lot of different contexts for this. So this might actually be the hardest law just because you have so many different ways you can be asked the question. But the simplest version of this law is pretty easy. The total pressure of a system is equal to a sum of all the partial pressures. If I told you that there was a trimix blend of gases in a scuba tank for somebody who's going to dive deep in the ocean that had 300 psi oxygen, 600 psi nitrogen, 2100 psi helium, the only thing you'd have to do to know the total pressure of the system is just add up all those parts, right? So I just add them up and I'd get what looks like 3,000 total PSI here. Remember, I would have to talk about sig figs, so since all those things were the hundreds place, I should probably have that mark over that zero there. But that's as simple as this law can be. That'd be 3,000 PSI total. But there are other complicated versions of it, right? Maybe I told you that the total was 3,000, and I told you that you had 300 and 600 for the oxygen and nitrogen, and I'd ask you what is the partial pressure for that helium? So it's the same thing, you just do the opposite, you'd subtract from that total to get one of the parts that's missing. Otherwise, this can turn into a percent problem too, right? 300 is 10% of 3,000. So I could have told you that 10% of this tank is oxygen. I could have told you that 20% is nitrogen, and you probably could figure it out because it's got to be 100 total. 70% of that mixture is helium, right? And I could work off of that as well. So it could be a percent problem. It could be parts, add them up to equal a whole, right? Let me show you what the percent problem might look like. So I have a percent of some gas in a container. So it doesn't really matter what the percent is. Let's say that it's 20% helium, right? The total pressure of my container is, let's say it's 10 atmospheres, right? We'll make this at least 2 sig figs for that 20%, but 10 atmospheres total, right? In order to figure out the partial pressure for my helium, all I have to do is figure out what 20% of 10 is. So I can do that by setting up as a ratio if I want to. I can always do percent over a total, which would be 20 over 100 in this case, is equal to some other part over a total. Excuse me. The total is actually 10 in this case. And solve for what's missing. So I know that because this is pretty simple math, since this 10 is 10 times smaller than 100, then x is going to have to be 2. But I need 2 sig figs, 2 atmospheres would be more partial pressure for helium in this tank, in this system, whatever it is. And I could tell you that that system is a mixture of helium and argon, maybe. Excuse me. And then I could ask you at this point, all right, so what's my partial pressure for the argon? If helium and argon are the only 2 things in that system, you know that the total is 10. So 8 plus 2 equals 10. 8 atmospheres of that pressure is going to be attributed to that argon gas. So again, you can do percent problems. You can just add up the parts to get the total. Again, the original law is in here, just looking at 2 plus 8 gives me 10. So that's the original law, but there's just a lot of different contexts for it. Remember, if you're doing a percent problem, percent over 100 equals some part, right? My partial pressure I didn't know in this case over a total. That's the thing I did know. So whatever's missing, you can always solve for it and just do what you got to do. Sometimes I can have it look a little bit different. I could tell you that there's 1 mole of helium, 2 moles of argon, maybe 7 moles of krypton. Just picking noble gases here, right? If you have this mixture in a container and you were told that the total pressure was, let's say it's 20 atmospheres this time, I can still figure out what part of that 20 atmospheres is attributed to each gas, because as long as I know mole amounts, right, I can always set up ratios. I can do the same thing I just did. It's just not a percent, right? I have 1, 2, and 7. I have a total of 10 moles in this container. So again, part over total equals another part over total. I can just set it up and say, okay, so 1 out of 10, right, that's my helium. So I could set it up and solve for X out of 20 total, how much of that pressure is attributed to helium. Again, if I solve for X, I would find out that, 2 atmospheres came from the helium, whereas argon, being twice as big, is probably going to be 4 atmospheres, right? But I could solve for that by setting up 2 over 10 equals X over 20 and just do what I got to do, right? That would still give me 4 atmospheres. I can't do a direct conversion from 2 to 7, so I might think about just setting it up and doing what I have to do, right? 2 is 3.5 times smaller than 7, so maybe I could take 4 times 3.5. But again, 7 over 10 equals X over 20. I could solve for X that way, but I also could just be smart. This is 6 total, right? 2 plus 4 gives me 6. It's 20 total. I'm pretty sure that I'm going to have 14 atmospheres attributed to that krypton, or this whole thing wouldn't work, right? Again, don't ever forget about the parts adding up to equal the total. That actually makes this law super easy in the long run. So you can always set up part over total equals another part over total. If you have mole amounts, you just set up a ratio, right? 1 mole out of 10 moles, or maybe it's 7 moles out of the 10 moles total. But this is my total pressure, this 20 atmospheres down here. I'm solving for the part. I could also do it the other way around. I could tell you that a tank had 2 moles of oxygen and it had 3 moles of nitrogen in it. And I could tell you that the partial pressure for the oxygen itself, not just write part there, I'd actually put the O2 symbol there. The partial pressure for the oxygen, this is just a shorthand for that, would be, let's say it's 40 torr. Doesn't really matter what units we use. So if the partial pressure for the oxygen was 40 torr, you could use the information given here to figure out what the total pressure is. You could use the information given here to figure out what pressure is attributed to the nitrogen as well. So if 2 moles out of the 5 moles total, that's the first thing you need to do, are oxygen, 2 out of 5, what's the total pressure in this system? Now, I'm doing the same thing I did before. I'm just going to know the top value, the part value, the partial pressure. I'm not going to know the total pressure, right? But 2 out of 5 as to 40 out of what, right? 2 times 20 is 40. 5 times 20 is 100. So I must have a total pressure of 100 torr, which again, if I want to figure out what part of it is nitrogen, I could go 2 over 5 equals x over 100 now, but I also could just subtract 40 from 100. And I could figure out that 60 torr is attributed to that nitrogen. Again, I'm throwing a lot of different kinds of examples at you, but it's not supposed to be hard. It's supposed to be pretty logical. You can always set up ratios to get answers for these things, whether it's a mole question like this one, or if it's a percent question like this one here was, right? I can set up that ratio that's always a part over total equals some other part over a total, right? It doesn't really matter what kind of thing it is. Percent is out of 100 total. So I can always set up ratios. I can add up parts to get the total value, or I could subtract from that total value. I could subtract parts that I know from the total to figure out what my parts are. So there's a lot of different contexts for this. You're going to try a worksheet that goes with this. Just do the best that you can. If you can't figure it all out, we might just have to talk about it when I get back. Otherwise, that's your partial pressure video.